boosts your productivity, gives you a different workflow to try, or maybe interests you inside of the Autodesk design applications that we sell and support here at Man and Machine. The idea behind this session today is I want to talk for, let's say, the next half an hour or so about using Inventor to drive some automation. But I'm going to do that maybe using some different workflows that you may not have seen before. More specifically, what we're going to do is we're going to tie a construction product in Autodesk Revit with a manufacturing product with Autodesk Inventor and link the two together using a piece of technology that sits inside of Inventor called ilogic. ilogic is a coding interface that sits directly in Inventor. It's off the shelf. You don't need to pay any additional money on subscription, and it essentially allows you to write .NET framework code, so VB.NET, directly into the Inventor interface to automate things that otherwise you would have to do manually. And one thing that I really like doing recently is pushing a workflow between the likes of Revit and between Inventor, and using some simple functionality like a schedule inside of Revit and using that to drive an automation inside of Inventor. And that's what I want to share with you today, because we've talked through this kind of process before using ilogic purely inside of Inventor. But I kind of want to leverage that out and maybe go a little bit wider with regards to the workflow, share with you perhaps what it could do for you, especially if you're sort of cross-discipline or work within, products within the construction space. So we're going to go through it. It's going to be quite high-level, concept-y, but I want to show you a working example that's very easy to understand and hopefully very easy to follow. So we're going to be live inside of both Revit 2025 and Inventor 2025. This workflow would work actually back with older versions of those applications as well, but hopefully it gives you a good sense of A, what we're all about and what we can help you with, but B, what's possible now inside of these tool sets, so long as you've got the time and experience to. So without further ado, I'm just going to shrink myself down into the corner. Oh, so I pressed the wrong button on the button box. There we go. I'm going to shrink myself down into the corner, and I'm going to go ahead and share my screen. So what we're going to do is we're just going to do a really simple scenario. So let's say that I'm a product manufacturer and I manufacture a really simple product. It's a box. And that box sits in the construction space and is placed around a construction site, for example. And what I want to do is I want to offer a solution that can be sized and scaled to fit a scenario in the construction space. But then I want to be able to pull the information that's being used in and around that space, extract it into Inventor, and then use Inventor in order to automatically create fabrication models, assemblies if necessary, and or drawings. So I'm actually going to start this process inside of Revit, believe it or not. So I'm going to open up Autodesk Revit, and this is going to really build up a fairly small part of the workflow today. But what we're going to do is we're going to open up a fairly simple model, and we're going to place down some componentry. So what I've done prior to this is I've modeled up a component for this particular example. So I'm going to place it in from my desktop. I've got a folder called Automation Webinar, and I've got this file called Box. So it really is a very crude example, and I'm just going to place a few of these down on top of this surface. I'm not really that fussed about how many I place, but I'm just going to place a handful like so. And then for each one of those, I'm going to go ahead and customize them. So this first one, I'm going to leave as it is. It's about 500 by 500 cubed. The second one, I'm going to select it. I'm going to edit its type, which is telling Revit I'm going to change its properties. In there, I'm going to duplicate it so that I can edit it on its own. And I'm going to make it 0.5 meters by 325, and I'm going to make it 700 high. Whilst I'm in there, I'm going to give it the type mark box-02. So I've changed 4 properties against that particular box. Let's go back to our first box and actually give that a type mark box-01 for the purpose of this. So what I'm doing is I'm giving these boxes an identification number, and I'm also telling them that they're different sizes and shapes. And that's really what's important from this perspective. I'm going to be quite rushed. I'm going to do this quite inaccurately for the purpose of this. But what you're going to see is, make sure you duplicate it first. What you're going to see is 3 different versions, or 3 or 4 different versions of component that sit within inside this space. It doesn't really matter what these are for the purpose of today. What matters is what we're able to do inside of Inventor after we have created it. So let's go ahead and just duplicate these last 2. So let's say box 4 is going to be 50 by 250 by 317, something obscure. And let's call this one box 04. So I've got components which I've given an identity number inside of Revit. 4 different types of component. One of them has 2 instances. So in other words, 4 different types of components. And then what I'm going to do is I'm going to create a schedule in Revit. So these have been built with shared parameters. That means that I can create a schedule inside of Revit that contains all of the information around those components. This is really straightforward from a Revit perspective. It's just a generic model that I've built this from. And what we're going to do is we're going to take across the width, which is a shared parameter. We're going to take across the height, which is a shared parameter, the depth, which is a shared parameter, and also we're going to take across, I think I called it the type mark, there we go, and the type mark. So the type mark's my ID, so I'm going to put that first, and then I want the width, then I want the depth, and then I want the height. I'm going to go ahead and say that I want to sort them first by their type mark, then by their width, then by their depth, and then by their height. I don't want to itemize every instance, so I get one listing for each type of box. And hey presto, what I have in Revit is box 1 is 250 by 250 by 250. Box 2 is 700 by 500 by 325, so on and so forth. And yes, this is a very simple example, but you can imagine how what you've got there could scale to any number of parameters and be as complex or as simple as you would need it to be. So what we're going to do based on that is we're then going to say File, we're going to come to Export, and we're going to go and export this out using the schedule format. This will allow me to save this as a CSV. So on my desktop, I'm going to save that in this automation webinar folder as generic model schedule.csv. And I'm just going to untick all these boxes. I just want a flat list of data and press OK. That'll just take a couple of seconds. And what I'll be left with is a file that looks a bit like this. So it's really, really simple stuff. It's just got these 4 lines. There's my ID, there's my width, there's my depth, and there's my height for every single type of box. Inside Inventor now, I'm going to say that I want to create a new file. That file is going to be an assembly, because what I want to do is I want to get Inventor to generate for me parts for all of those components that have just been modeled up inside of Revit. And I want it to take across a number of pieces of properties and use them to build up those components. For some reason, my new file dialog box is not showing up, which is a little bit frustrating. Is it on a different screen? Yes, it is. Let's start a new assembly. And I've got a simple piece of ilogic to do that for me. I'm not going to go through the code in the nth degree of detail today, just because, quite frankly, we don't need to for this example. What's more important is you seeing how this is working, why it's working, and kind of appreciating what it is it's doing for you. Okay. And again, the crux of it is we've got a design inside of Inventor that we're going to drive all the fabrication outputs for automatically based on what's been placed inside of Revit. So if you can imagine that you're a manufacturer of, I don't know, facades, equipment that goes around the outside of a building, equipment that's placed several times within a building, be it casework, furniture, whatever it might be. We can have a schedule that's produced from the Revit output that gives us a list of data. We can then use that schedule to drive automation inside of Inventor. Because in some cases, Revit is far better at placing equipment around a building, certainly from a scale perspective. So what I have is a piece of ilogic here. And this ilogic, again, I'm not going to read this through completely line by line, but to give you a bit of background, this is VB.NET code, okay? The editor's directly inside of Inventor, as I said earlier, and that editor is, it comes out of the box. You don't have to pay any more for it. It's not an additional subscription. It comes with Inventor. So what we're doing is we're defining that we're working in an assembly. I'm telling it to go and pick up a number of templates for this fabrication component. And I'm telling it to go and pick up the schedule that I've got inside of Revit. From there, I'm then telling it what information it's going to find. And I've got within my part templates for my box, a box ID, a width, a depth, and a height parameter that I'm going to drive from this Revit schedule. Okay, so let's just say close and show you that I have a completely empty assembly. There's nothing in it, no parts at all, completely empty. But what I am going to do is I'm going to right click and run this rule. It's going to be fairly quick. And before I run it, let's just show you this folder. Let's do a little refresh here. You can see this folder is completely empty. All I have is a templates folder that's got a template box and a template drawing of a box. I'm going to run this rule, which will go and look at that Revit schedule, and it will go and pull the information off that schedule and place 1, 2, 3, 4 components inside of my assembly. I'm just going to do an update there. The constraints aren't working particularly nicely for me here, but what you can see is I've got 4 different boxes. Let's just isolate them down. So let's come to this first box here. And the first box I placed in Revit was ID'd box 01. So I've got engraved on the top of this box, box 01. And you may remember that that box was 500, sorry, it was 250 by 250 high. So I have a cube now inside of Inventor with the same ID that exists in Revit, and it's 250 by 250. My second box, if I choose to undo my isolate and then re-isolate my second box, which was box 02, and the size of this box was in the width 700, in the height 325, and in the depth it was 500. Again, matching what we had inside of here. So what we're doing is we're getting the system to generate us individual parts, and that's important. What we have here is physically separate parts. Let me refresh this folder again, and you can see that I've got a separate folder for each one of those different types of box. Yes, they're named the same. I did warn you this was a very crude, high-level example today. But I've got a different part file and a different drawing file for every single different box within that design. It could very easily call these different things or give them different part numbers that could be generic, or they could be driven based on the size, for example. Each one of these, if I go into this small skinny one on box 4, I'm going to right click and open the drawing view. Each one of these has its own drawing file. And you can see that this file here, which was box 04, is 50 by 317 by 50, which is the exact dimensions that I typed in for that final box. So for every one of these parts, we have a fully detailed, not detailed for this example, but for what I'm talking about, a fully detailed fabrication model that would have its properties, its physical material, its center of gravity. This could be a wider assembly with a bill of materials and all sorts going on. It's driven parameter values to drive the dimensions within the sketches and within the features. And then each one of these is giving me its own drawing output. Yes, you may need to go in and tidy up some of the individual drawings based on the scaling sizes, and we could automate that using some ilogic rules. But simply put, we can drive automation inside of Inventor via Revit. So anything that you are placing around a Revit model, again, whether it's furniture, casework, pieces of metal, structural information, facade information, whatever it might be, we can take that information, export it on a schedule with a list of properties, and then use those properties to intelligently and parametrically drive a model or models inside of Inventor using ilogic. It's a very different example to what we've maybe shown you before, but using this workflow, hopefully you can see there's a fair bit of value there which will enable you to really work well moving forward. Certainly automating this kind of thing is a huge time saver. If something changes in Revit, you change it in Revit, you rerun the rules in Inventor, and hey presto, your design is up to date. Yes, I know that you also have functionality. Let's just stop sharing the screen now because we probably don't need that anymore. Now, I know that you've got functionality directly inside of Inventor to link it with Revit. We can export to Revit using the BIM content tools. We can bring Revit files and project files directly into my camera. Stop following me. Let me just wave at it for a little second. You can bring Revit projects directly into Inventor to work on them, which is great. And that workflow is fantastic if you are designing a single thing within a single space, whether it's a weld bay for a factory, whether it's a bit of casework for a specific space. But what this is enabling you to do is say, okay, well, our component is hugely customizable and massively configurable and can be placed anywhere around the building, and we could have any different size or configuration of that component around that building. By doing it this way, you can say to the architect, to the guy that's in charge of the FF&E for that particular construction project, place this component as you need it and drive the parametrics in this component as you need it, using an intelligent Revit-based family that will scale and work the way you want it to. Put together a schedule in the right order. Tell Inventor how to read that schedule. With that schedule, which template parts should it use? How should it drive them? How should it deal with the parameters and the constraints around the assembly? Should it be placing a part? Should it be placing an assembly? And what does it do with the drawing? This crude example today could be scaled hugely inside an organization if necessary to completely automate your fabrication outputs based on a Revit drawing. And really, today, that's all I wanted to show. Something a bit different to the norm, hopefully something useful that shows you maybe a little bit of low-hanging fruit to begin with, but B, perhaps something that you want to get in touch. Reach out, tell us the kind of things that you're working on, and have a conversation with us. Is there something there that we can help you with, point you in the right direction about this kind of automation? And whilst I've given a Revit-based example here, that's just one example of many that we can work through to get these systems linking together. So yeah, from me, thank you ever so much for watching. A short and sweet one today, but that's a workflow of linking Revit and Inventor together, not using the out-of-the-box tools in Inventor for linking Revit files, but by using ilogic to automatically drive a parametric fabrication model using Inventor automation. Thanks very much, take care, and I'll see you next time. Bye-bye.